I'm Tim Komar, and today we are going to take a look at an example of Taylor series along with integration. The problem that we're going to look at today is that we are going to approximate the integral from 0 to 0.5 of sine of x squared to within 10 to the negative 6. So the Taylor series for sine x, centered at x equals 0, also called the Maclaurin series for sine x, is given here as follows. So sine of x is equal to the power series here, -1 to the n, times x to the 2n plus 1, divided by 2n plus 1 factorial, as n ranges from 0 to infinity over here. And we have the first couple terms written out over here. We find the Taylor series for sine of x squared, centered at x equals 0, simply by substituting x squared for x in the series above. And we see that here where the x is substituted in here in red, and the first couple terms are written out here on the right. So because the Taylor series above for sine x converges for all real numbers, the Taylor series above for sine of x squared also converges for all real numbers. And since the Taylor series for sine of x squared converges for all real numbers, we can integrate term by term as we have done here. And this series also converges for all real numbers. Now we have our definite integral for sine of x squared here, written out in its exact form over here in terms of the Taylor series. And using the fundamental theorem of calculus, of course, we're going to evaluate this at 0.5 and evaluating it at 0 and subtracting. If we evaluate it at 0, we get 0. So this just turns out to be this infinite series over here, the first few terms of which are written out here. So that series above is convergent, and it's an alternating series. And we can use the alternating series estimation theorem to approximate it. We note that the absolute values of the second and third terms in that series are as follows here. This one is just a little bit bigger than 10 to the negative 4th. This one is just a little bit bigger than 10 to the negative 7th, but still less than 10 to the negative 6. So since the absolute value of this third term here is less than 10 to the negative 6, we can approximate the series using the first two terms. And here is our approximation of the integral, which comes out to be approximately 0.041481. Thank you.